4.1's about congruent figures. So when you take a look at our boxes down here, what we want to do is we want to take a look and see naming the congruent figures. So they say A, B, C, D is congruent to E, F, G, H. And again, you try to match up the angles where you need to, but the greatest thing about this is that wherever the letters are, they match. So see how AB is first and the EF is first? That's why AB is congruent to EF. Okay? And then in the next, let's take a look at angle D. Well, what does it match with? It matches with H, so angle D is congruent to angle H. That's what's nice about it. Yeah, you could flip the figure and everything else and match it up, but as long as they give you the names, use the names to name the congruent figures. Okay, so in 4.1 third angle theorem states that if two angles on a triangle are congruent, the third one has to be congruent. So angle A congruent to angle D, B congruent to E, that means C has to be congruent to F. 180 degrees in a triangle, that's always got to be that way. In problem 1 here, they talk about finding congruent parts, and they give you if Hij is congruent to Lm and O, what are the congruent corresponding parts? You can try to flip these around and match them up, but I'm going to just go ahead and look at my name here. Okay, find the congruent parts. Well, let's start with our sides. I'm going to start with the first two letters. Hi is congruent to, well, what's it match up with? Lm. I'm going to go to the next one. Ij, what's it congruent to? Mn. I'm just going to go right down the list. Jk, what's it congruent to? No. And the last one, I'm going to take the first one, which is H, and the last one, which is K, and that's going to be congruent to the first one, which is L, and the last one, which is O. Now, if we're looking at the angles, that's even simpler. Angle H is congruent to angle L. Angle I, which is the second letter, is congruent to the second letter, which is angle M. Angle J, which is the third letter, congruent to angle N. And angle K is congruent to the last one, which is angle O. And this is why it's important to how you name your figures. Problem 2 says using congruent parts. We have congruent triangles here. Now, they don't give me the names, but if I look, and my drawing is terrible, but BC is going to match up with EF, BA matches up with ED, and AC matches up with FD. So angle C is going to match with angle F, angle B with angle E, that's a 30-30. So you kind of flip it on top. So they want to know what's the measurement of angle D. Angle D is right there. It's going to match with angle A. So if we have 30 and 75, we have to find angle A. So angle A plus 30 plus 75 is going to be 180 degrees. I get angle A plus 105 equals 180. Subtract the 105, so I get angle A equals 75 degrees. Okay, well, angle D matches it, therefore angle D is also 75 degrees. Problem 3 wants you to say, are the triangles congruent? They want you to justify your answer. So right now they give us that AB is congruent to DE, or ED, that's fine. AB is congruent to DE because it's given. Okay? We know that BC is congruent to DC because they both equal 4. We know that AC is congruent to EC because they both equal 6. So all three sides of the triangle are congruent. Great, done. What about our angles? We know that angle A is congruent to angle E, and we know angle B is congruent to angle D because they're both given. Okay? Well, what can we do? We need the third angle. You need all three sides, all three angles to talk about triangles in this particular section. So if I look here, what can you tell me about this angle here and this angle here? Those look really vertical to me. So I can say angle BCA is congruent to angle DCE by vertical angles. Therefore, triangle ABC is congruent to triangle EDC. If you want to put something in there, you put by definition of congruent triangles, but as soon as you get all three angles congruent, or all three sides, I'm sorry, and all three angles congruent, you're fine. Problem 4 talks about proving triangles congruent. They give us a bunch of givens, so I've kind of already started my statement of reason box down there and listed the given in there. So what they say is LM is congruent to LO and MN is congruent to ON. Those are our sides. So we have 2 of the 3 sides congruent, so we need the third side. And then they tell us angle M is congruent to angle O, and then angle MLN is congruent to angle OLN. Those are all given to me, so it's 2 out of 3 angles and 2 out of 3 sides. So we need to get the third angle and we need to get the third side into our proof. Okay, that's going to help us prove triangles are congruent for today. And we'll learn other theorems and postulates that will help us to prove triangles so we don't have to do all this. But for our stuff today, we want to make sure all 3 angles are congruent, all 3 sides are congruent. So if I take a look here, what can you tell me about an LN and LN, right? If we look in our triangle names, LN and LN match. Well, look at LN. Isn't it the same side? So again, this is what's going to become your best friend. LN is congruent to LN. Why? Because of the reflexive property. Reflexive property is going to be huge. Okay, well there's the third side. So we have all 3 sides. Now we need the third angle. Okay, we have this angle over here. Once you have 2 angles congruent, that third angle theorem becomes into play here, which is nice. And we just talked about that in the early part of it. So I can state that angle MNL is congruent to angle ONL by the third angle theorem. And what that simply says is if 2 angles of a triangle are congruent, then the third one has to be congruent. So then I can state triangle LMN. Sorry, thought I was putting an angle in there. Triangle LMN congruent to triangle LON by definition of congruent triangles.